All right. This is part 3 of variable coordinates or coordinate proof, where we're just trying to get really comfortable understanding how coordinates relate to things on here. So for some people, this particular problem is so incredibly easy. For others, they're like, "What the heck are you talking about?" So if this point over here is 6 units away, the one up here is also 6 units away. Some people in class will say that's 6 comma 6, and then they rethink it and they change their answer. I often ask the question, where's the center of the circle? And people realize that point is 6 comma 6 because you're going right 6 and up 6. The radius is common there. So if I were to go over here to A, that distance across must be 12, must be the diameter of the circle. So A has got to be 12, and the vertical distance must be 6 because you're using that radius in any direction you want. That's all that problem was really asking you to do. Nothing too big. Just trying to get you to take a look at circles and be thinking about radii as we go through this. This is where we actually get to an actual coordinate proof. We're not going to do a ton of these just because we're doing remote learning, and it's not something I like having people learn via YouTube. That shape that you see right there is called a kite, and eventually we're gonna put you're gonna find the missing coordinates of the sides of the kite. But before we do that, I'm going to give you the points on the kite. 0, 0 over here. And you might not know a ton of properties about kites. That doesn't matter. I've sort of avoided that, having you know that part of it. You're going to like my coordinates. I'm not going to use a comma 0 down here on the right. There's a reason I'm using 2a comma 0. You'll figure it out later on. These other 2 points technically have no relationship. You can't find these 2 from that first one. So I'm going to give those to you in a minute. The next one up here on the right is 2b comma 2c. Again, they have nothing to do with a. It's part of how kites work. And the last one, unfortunately, there's no way to get this one from these 2 unless you knew some angles here or something. So this is 2d comma 2f. And of course, we're back at the origin over here for this kite. So the task again is to supply the missing coordinates for the midpoints of this side, and this side, and that side. So you have 1, 2, 3, 4 answers you're looking for. Just to shoot those images up there in yellow. Find those 4 points. And pause this thing and come back to it. So usually the bottom one's easy. You probably know why I called this 2a, because if you're at the midpoint, you're just going halfway. So that first one should just be a comma 0. You're the midpoint of 0 and 2a. You're at a. Similar idea here, and a similar idea here. It's probably easier to do this one next because 0, 0 is one of the points. What's right between 0 and 2d? D. What's between 0 and 2f? F. So that one hopefully makes sense. At that point is D comma F. So I'm going to find these other 2 midpoints here in just a moment now. If you're fast to find a midpoint, you could just go straight in, jump in, and use that midpoint formula. Add that, and divide by 2. Add that, and divide by 2. You're just taking the average of the x's and the average of the y's, and that's the idea you should have hopefully comfortably in your mind here. Between 2a and 2b is a plus b. And it sounds a little funny to say that, but trust me, take the average of those 2 and you get a plus b. And then between 0 and 2c, of course, is c. Now the last one here, the last one has to be... Hey, Tristan, stop. So the last one has to be in terms of all variables. So you're the middle of 2D and 2B and the middle of 2F and 2C. Hopefully you average those out and you get something kind of messy, D plus B and F plus C. And you can rearrange those if you want to put those in alphabetical order, that's fine. So that's just the intro to this. We just put something on there in terms of coordinates, and then I want you to use the slopes of this shape. If I were to connect these 4 midpoints and make a quadrilateral and call it quad, I want you to figure out what kind of shape that quadrilateral is. Is not the kite, but is this shape connected by the yellow dots? Is that thing a parallelogram, a rectangle, a square, a rhombus? What can you figure out? And I want you to do it using slope, as it mentions somewhere in here, using slope. So you'll see we can't do this numerically. This is a question asking you to use coordinate geometry to prove something about every single kite in the world. If you find the midpoints of the sides and you connect them, you'll get this type of figure, always. That's what we're after. So I'm going to do this, four-step process here. I'm going to find the slope of this top side here, which I've kind of shown in red. And of course, you find slope by finding rise over run. You find rise by subtracting the y's. So I'll do that first. F plus C minus F should give me the rise along this part. Do the same thing with the run. D plus B minus D should give me the run. Now, that's a mess. So if you clean up coordinate geometry, you should get a simplified answer. If you clean that up, F's it looks like cancels. You clean that up, the D's cancel. I'm going to do this for all four sides, and it doesn't matter which order you do it in. What the heck, I might as well try the bottom to see if there's anything comparable from the top and the bottom. I look at those and I say, they might have a relationship. Same idea on the bottom. The rise from here to here is C, or C minus 0. And the run from here to here is just B units across. A plus B minus A. And again, if I simplify that and I simplify this, something interesting might happen. Here we said C was left over. We notice C is left over here. The D's canceled. We have B left over. And all of a sudden, we've got an aha moment here. You get C over B for both of them, which is telling you something. What is that telling you? Bingo, they're parallel. So try that for the other two. I'll reveal that in a minute here, what you should get for the other two sides. You got one set of parallel sides. Maybe it's a trapezoid. Let's see if the other two are parallel or not. So the slope for this right side, your rise is going to be F. And your run, if you clean it up and subtract these, is just D minus A. Do the same thing with the left side. The rise there, it's probably obvious, is F. And the run, and I have to be careful what order I subtract in here. If I do F minus 0, I'm going to do D minus A to be consistent on here. I could have done this, and these are both negatives. A negative divided negative would get me back to positive F over A minus D, or D minus A would get me to the same answer. Sometimes you'll end up with things that are algebraically, they look different. If you clean them up, they simplify to the same thing. So bingo, I've got another pair of slopes that are the same, which reveals that this thing is definitely a parallelogram. And this is true for every single kite in the world. If you have a kite and you connect the midpoints of the sides, you'll always get a parallelogram. That is always true. Don't try to argue with me. We just proved it. Nobody can argue with this. Hopefully that makes sense. Give the homework a try. I'm going to come back in the last part, actually, and show you this one.